Whenever the entire expression is underneath a square root sign, when we square it, the square root and square root sign cancel out, and you're just left with what is inside. So that is the ideal situation. On the left side, though, we don't have that. We have an extra +1 hanging out here. It's not underneath the square root. And so we're squaring this entire thing. When you square something, it means you multiply it by itself. So we actually have square root of x plus 2 plus 1, and we're going to multiply that by the square root of x plus 2 plus 1. So that little exponent of 2 means take this value here and multiply it 2 times. Multiply it twice. And so that's how we're getting to this line, is we actually do out this multiplication. It's kind of like the FOIL method where we'll take the first term and multiply it by each value here in the second polynomial. So when you do that first multiplication, the square roots would cancel out and you just have x plus 2. But then when you take the square root of x plus 2 and multiply it by the 1, you're going to get the square root of x plus 2. And then after we've multiplied this by both of these terms, we move over to the 1 and multiply it by both terms. So when you do the 1 times square root of x plus 2, again, you just get the square root of x plus 2. And then you do 1 times the 1, and you get a 1. So when you simplify that all down, we'd have 2x plus 2s. That's where they're getting the 2x plus 2s. The 1 plus the 2 is how they're getting 3. And then you just have an x hanging out there. So that's how they arrived at that solution.